Okay, so we talked about graphing lines where we said we had to look for a slope and a y-intercept. And what a line does is it plots all the points, or it shows you every single point. It's an infinite set of points that satisfy a given equation. So when we talked about lines, you had something happen here. And every point that was on this line made the equation true. So if this were just x plus y equals -6, all the points on this line would add to -6. I apologize. But here's what's happening now. Now I want to know what's greater than or equal to. Okay, so let's think about a few numbers, a few ordered pairs. We want 4 solutions. I'm going to show you the ordered pair 0, 0. That is a solution to that because when you add 0 to 0, you get 0. And isn't 0 greater than or equal to -6? Yeah. Okay. Now let's think about, let's look at 0, -6. When you add that, you get -6. And isn't -6 greater than or equal to -6? Yeah. Let's go ahead and throw 6, 6. When you add 6 plus 6, you get 12. 12 is greater than or equal to -6. And then -6, 0. Again, it equals -6, but it's greater than or equal to. So what I've done is I've taken everything within a line and I've actually extended more solutions. So instead of just being on the line, for this one, I'm going to be on the line and I'm going to be above the line. So any number, any ordered pair I pick within this region or on the line itself will make this a true statement when I substitute. So that's what we're doing. So a line cuts a plane into 2 parts. But whenever we talk about inequalities, we want to talk about the region above the line or the region below. You'll see. All right. So let's see if the following are solutions to x plus 3y equals -2. And the reason we want to do this is sometimes I want to know, is my region correct? So let's choose a point here. So when we look at the point 2, -6, we're going to let x equal -2. We're going to let y equal -6. So does 2, oh goodness, poor craft. Let's try again. So let me do my way. I have x plus 3y. I want to know, is that less than -2? So does 2 plus 3 times -6? I want to know, is that less than -2? Well, 2 plus 3 times -6 is 2 plus -18, which is -16. Is that less than? Yeah, it's true. I get a true statement here. So, yes, this is a solution because when I substitute x and y, I do get a number that's less than -2. So let's look at this one. So we're looking at x plus 3y. Is that less than -2? So is 4 plus 3 times -2 less than -2? Oh, goodness, Denise, slow down. So this is 4 plus -6. Is that less than -2? Is -2 less than -2? Guys, that's false. It's not less than -2, it equals -2. This is a no. Okay, so talk to me, Robodeer. What's happening? Well, when we're talking about a line, you see how this is strictly less than? That means we cannot equal the line. Remember when we graphed just inequalities on a number line, we used a closed circle to show that we could equal the number and an open circle to show that we cannot equal the number? This kind of carries from that. The question is, how do you show a closed circle on a graph, or a series of continuous closed circles on a graph? Well, okay, so when you show a series of closed circles, remember, you fill them in. Okay, that looks like a line if I put them close enough. Now let's look at a series of open circles. I've got space there, so I've got openings in there. So what we're going to do is we're actually going to look at solid lines, and we're going to look at a dotted line. So I guess I need to actually move this over there. So a series of continuous closed circles. When you put all of them close together, you do make a dotted line. When you put a series of open circles, there are spaces in the line. So we say it's a dotted line. Now here's where it gets silly. I say dotted, but when I draw, I end up making a dashed line. So dotted, dashed. Just know it's not solid. That's really what I'm getting towards. That's what I'm looking for. I'm not a solid line. So if our inequality is greater than or equal to, or y is greater than, if you think about what we did up here where we were greater than, we ended up shading above the line, the boundary line. Oh, by the way, this is called the boundary line. My bad. Okay, so our boundary line is going to separate our plane into two parts. And if we see that y is greater than, or y is greater than or equal to, we'll shave above the boundary line. If y is less than or equal to, or y is less than, we will shade below the boundary line. Okay, so when I look at these two, I want to look how y compares to the inequality. Well, it's got all this stuff attached to it. So let's solve for y. Thank goodness we practiced that as well. So we'll get negative 7y is greater than negative 3x minus 14, because you know those zeroed out. Now we're going to divide by negative 7. Uh-oh, when we divide, it turns around. The inequality turns around. So we get y is less than. I really don't care about this. I mean, I want it to be correct, but that doesn't matter. All that matters is this. Okay, so we'll have a dotted line here, and we will shade below. Okay, now let's look over here at this one. Oh, I need the y on the left side, so I'm just going to turn all this around. So see how y is greater than that? We're pointing to the smaller number. Well, when we turn this around, we need to make sure our inequality points to the smaller value, the 5x plus 8. So this tells me I've got a solid line, and I am going to shade above. And there it is, all right? So when we do that, that actually carries us into the next thing. So we're going to be graphing lines here. And I need to get my ruler. Darn, I thought I had everything together. Okay, so let's look at y is greater than 2. Okay, so y is greater than 2. There's no x there, so there's a zero slope happening. And remember, when there's a zero slope, your line is horizontal. Anytime you have just y equals, it's a horizontal line. When you have x equals, it's a vertical. Oh, let's go over something else. Let's go ahead and plan our shading and our dotted line and our dashed line. If y is greater than 2, that means we're going to have a dotted line, and we are going to shade above. So I go to where y equals 2, and I'm going to make this a dashed line. okay? And then going to shade above. Okay, so here's what this means. What does this mean, Robodeer? Well, pick a point. Pick this point. 1, 2, 3, 4. 1, 2, 3, 4. This point is 4, 4. How does it check? Well, all that needs to happen is its y coordinate has to be greater than 2. Is it? Yeah, it is. Another way that we used to teach this is to choose a test point. Choose the point 0, 0. Okay, the origin. So what happens when x is 0? Nothing, it doesn't matter. But what happens when y is 0? Is 0 greater than 2? No. So that means this is the false region. This is the true region. Okay? This is the losing team, if you will. This is the winning team. Okay? That's how it works. Haves versus have-nots, all of that. Okay, let's look at this one. This one, I need to solve this for y. So let's divide everything by -4. So we have -4y divided by -4. Our inequality turns around, remember. We get 12 divided by -4 minus x divided by -4. Yeah, I should have turned that around already. It's okay. So we'll get y is less than or equal to -3 plus x over 4. Okay, that is actually, I'm going to go and write this in slope-intercept form. That will be 1/4 x because we're dividing by 4, so we're taking a fraction of x, minus 3. Okay, so here's what happens in an inequality. In an inequality, you can always tell 4 things about something right away. So here I can tell you the slope is 1/4. The y-intercept is -3. I know I'm going to have a solid line, and I know I'm going to shade below. Whoa, that's a lot of stuff. Yeah, but it's not bad. I mean, think about it. Y-intercept, -3. Slope, 1/4. I can equal, so it's solid. I'm less than, so we shade below. Y-intercept, -3. My slope is 1/4. 1, 2, 3, 4. And I can also go this way, remember? Let's go there. And it's a solid line. And we are shading below. All right, there it is. So what that means is if I pick any number down here, let's pick 0, -6. It'll be a true statement. So when you substitute -6 in here, you get +24. +24 is greater than or equal to 12. Check. Okay. Pick on the line, it'll equal. Oh, that's what I didn't do over here. Suppose you picked 2. Pick this point. What's the y coordinate? 2. Is 2 greater than 2? Nah, bruh. 2 equals 2. So be careful there. All right. Yeah, I'm a hot mess today. Sliding around. We'll make it though. All right. So, oh, we have a nice one. Almost. So I've got y plus 3x is greater than 1. Let's write that in slope-intercept form. And the way we write it in slope-intercept form is to subtract the 3x from both sides. And when I do that, I find that y is greater than -3x plus 1. So my y-intercept is 1. My slope is -3. I shade above a dotted line. Oh, dude, I did that so backwards. So my y-intercept is 1. My slope is -3. That says go down 3 to the right 1, down 3 to the right 1. Remember, that's over 1. Up 3 to the left 1. And it's dotted. and we need to shade above. So, Robert, how do you know when it's above or below? Well, pick a point. I was always taught to pick 0, 0. Pick the origin. Because when I put in 0 and 0, I get 0. Is 0 greater than 1? No, it's not. So this side doesn't get the point. The test point, he's kind of for everybody. It's like when you had to do a test review and your teacher would split you up into 2 teams. If you get the correct answer, if you get the answer correct, your team gets the point. Well, 0, 0 did not answer correctly, so his team does not get the point. The other team gets it. That's what we're doing. Okay, so once I've overwhelmed you with shading and all that, now I give you a word problem. Dude. Water bottles cost $5 each. Sodas cost $7 each. You want to spend no more than $58 on a combination. Okay, so once I see no more than, if you're not more than, you can be less than. Or you can be equal to. So let's start there. I know that something is going to be less than or equal to 58. Okay, let's think about what we have. I'm old school, so I'm going to try to define my variable. We're going to let W equal the cost of a water bottle. So 1 water bottle costs $5. 10 water bottles cost $50. 100 water bottles cost $500. What am I doing there? To find the cost of W water bottles, it's going to be 5 times W, right? Okay, keep that in mind. Well, let's go ahead and put that then. 5W. Now we've got sodas. Now, I don't like to use S's, but for teaching purposes today I will. So the cost of a soda is S. And I don't like to use S because sometimes I might get sloppy and it looks like a 5 and I've just totally messed up everything. So 1 water bottle or 1 soda, pardon me, costs $7. 2 sodas, $14. 3 sodas, $21. 10 sodas, $7. 100 sodas, $700. So again, to find the total cost of my sodas, I'm going to multiply 7 times S. And when I put these two together, we're adding them. So there's your inequality. Look at that, you wrote an inequality. You did okay. All right, now let's practice. Name 3 solutions to y is greater than negative 1/2 x plus 5. Ooh. I'm going to cheat. I'm going to go up here to 5, and I have a negative slope. All right, so I opened everything up. 0, 0 is a solution, which it is. Plug it in. Oh, just kidding. Is 0 greater than 5? No, Denise. So we need the stuff over here. Oh my gosh, that was a good lesson. I'm glad I did that. So I need stuff up there. So I can't choose 0, 5 because I cannot equal 5. I can choose 0, 6. Is 6 greater than 5? Yeah, all day. All right. Let's choose 6, 0. Is 0 greater than negative 3 plus 5? Is 0 greater than 2? Oh my gosh, that one. Yeah, it is. It is. 6 is greater than positive 2. Oh my gosh, I'm tripping. And then let's pick something like 5, 5. No. 5, 6. Because then when I take negative 1/2 of 6, no, oh my gosh, I'm having a moment. I'm sorry. Usually, this is always going to be like a practice the next day. As you can see, I'm doing a horrible job. Okay, let's pick 6, 6. So negative 1/2 of 6 is negative 3. Negative 3 plus 5 is 2. Is 6 greater than 2? Yeah, it is. So anything in that region will work. All right. Oh my goodness. That was kind of bad. I apologize. All right, so let's go to our next practice. Are the following solutions to y is less than x plus 2? So all I want you to do is write yes or no. So let's plug in here. So is y, all right, let's plug that in. So we have, is negative 2 less than 1 plus 2? Is negative 2 less than 3? Yes. We plug in here. Is 2 less than 0 plus 2? Is 2 less than 2? No, it equals 2. And now let's see what happens when x is negative 1 and y is 3. Is 3 less than negative 1 plus 2? Is 3 less than 1? No. All right. So those are that's how you check to make sure you did the work correctly. Just being able to substitute. For x plus 3 is greater than y, are the coordinates on the line a solution? No. The sum must be greater than 3. Okay. You cannot equal 3. The points on the line equal 3. You know when someone says like 5 o'clock on the dot, that means exact. They're right on it. The points on the line equal 3. So that's a no for me, dog. Okay, so that's how that works. All right. How do you change y is less than or equal to negative x plus 5 so that it is shaded above the line? Well, we just need to turn that around. That says shade below. So what if we turn it around to be above? All you need to do is be greater than or equal to. I mean, I could do either of these as long as we're showing greater than. All right, for each of the following, identify if you shade above or below, and if the line is solid or dotted. So here, this is solid, and we shade below. This one, we'll move the 2x to the other side. Y is greater than, and I don't care about that. I know this is dotted, and we shade above. Okay. This one, oh, I'm going to have to do some work. Negative y is less than or equal to negative 3x minus 4. When we divide, oh, turns everything around. So we get y is greater than or equal to, okay, solid above. Here we divide by negative 3, and that forces us to turn around our inequality. So when we reverse, we get y is less than 4x, dotted below. This last one, if 2x plus 3y, excuse me, if 2x plus 3 is less than y, let's turn that around. And when we do that, we are solid. No, we're not. Dude, we are dotted, and we shade above. Okay, so now we're going to do some graphs. And again, I'm glad we're doing this because it does help you review graphing equations in slope-intercept form. So we really are, y'all, just graphing equations in slope-intercept form. We're just adding a component where we have to shade, all right? And in order to shade, we need to solve for y. So for this one, let's divide by -2, which reverses our inequality. So we get y is less than or equal to -2 plus 3x, because this is -6 divided by -2. So this is y is less than or equal to 3x minus 2. That is a solid line, and we are going to shade below. Shade below what? Well, this has a y-intercept of -2 and a slope of 3 over 1, if you will. Dude, that's a lot of info, but you can pick it out. I mean, think about it. Y-intercept is -2, slope is up 3, to the right 1. You do it every day. How many of you can look at somebody and tell me 4 things about them right off the bat? Well, equations, inequalities work like people. You can always find something right away. We are making this a solid line. Oh, my bad. And we are going to shade below. All right, test a point. Test this one. 1, 2, 3. Test 5, 0. -2 times y is 0. Is 0 greater than 4 minus 30? Yeah, because that's going to be a negative number, and 0 is always greater than a negative. Okay? For this one, to solve for y, we subtract the x. We get 3y is less than -x plus 6. And now everything divides by 3. I really should write that in the next step, you know, but I sort of need the space. Okay, so here our y-intercept is 2. Our slope, so y-intercept is 2. Slope is -1/3, down 1, to the right 3, or up 1, to the left 3. It is a dotted line, and we shade less than is below. There we go. We are going to shade below. Okay, and again, choose 0, 0 as your test point. Is 0 plus 0 less than 6? Yeah, so we're correct. So to solve this for y, we add 5. So we get y is greater than or equal to -1/4 x plus 5. My y-intercept is 5. My slope is -1/4. We are solid, and we shade, above. Oh, look at that cover. Nice. So 5. 1, 2, 3, 4, 5. Oi. Okay. We're -1/4. So we go down 1, to the right 4. Oh, okay. So it's a solid line that gets shaded above. So guess what my answer is? That piece. Okay. So like if I pick this point, I should get a true statement. And that's the only one. Everything else ends up being below. Y is greater than or equal to 3. This is a horizontal line. We have a solid line, and we shade above. 1, 2, 3. Let's make this solid. And we shade everything above. So anything in this shaded region, if I choose its y-coordinate, the y-coordinate should be greater than or equal to 3. Boy, and this last one, negative 1/3 y is less than x. Okay, I don't care for the negative 1/3, so we're going to have to multiply by the reciprocal of negative 1/3, which is negative 3. But when we do that, remember, it turns around my inequality. Oh, we're going to have to multiply. Let me show you it multiplying. Okay, so we'll get negative 3 times x. So these will divide out. We get y is greater than negative 3x. Oh, what's my y-intercept there? What did we add to 3x? Nothing. What's the mathematical equivalent of nothing? 0. My slope is negative 3. We'll have a dotted line, and we'll shade above. All right, so let's see it. Y-intercept is 0. Slope is negative 3 divided by 1. All right, it's a dotted line. And on a test, I would make this really solid so you could see it and it would be obvious. And then I also extend the dot outside the plane just so you can see the dots or the dashes in the white space. And here, this is my top half, so we shade above. So pick a test point and you'll see that it's true. All right, we got to end with a word problem. Actually, let me end with a summary. So to summarize graphing, here's what we're going to do, okay? You have options here. You can either have a dotted line or a solid line. Oh, you could shade above or you could shade below. So when you shade above a dotted line, that is strictly greater than. When you shade below a dotted line, you are strictly less than. When you shade above a solid line, that's your greater than or equal to. When you shade below a dotted line, that's less than or equal to. So this is your line, and this is your shade. I'll have to find a way to pretty that up somewhere. Okay. Now let's focus on the word problem, shall we? Jeans cost $40 per pair, and shirts are $20 each. Write an inequality representing the amount of money. Well, J will equal the number of jeans you buy, not the cost, because they tell us the cost. And then shirts, again, I have to use S. I should just use F for flannel or, something. Number of shirts. So it's $40 per pair of jeans. Remember, per means multiply. Darn, that stuff is following us everywhere. And we put it together with 20 shirts. We want to spend less than $400. If you were to graph the inequality, would it be a solid line or a dotted line? Explain. It would be a dotted line because the total cannot equal 400. If you were to graph it, would you shade above or below the line? We would shade, let's do this. Since we're explaining, I should be a little more specific because like on the EOC, they'll ask us to do that. We will shade below, explain, because our total is less than. Okay. And there's everything, guys. A little extra. And I guess I'll stop sharing now. Thanks.